even easier, you can use Node.js internal cache module, module cache that will give a similar structure. So it's quite easy to have this kind of structure. And once we have this structure, we can actually start generating the bundle. This is the biggest code example we will have in the presentation, so try to hold on. What we can see here is that on the left side we mapped the previous. So from this we generated on the left side an object that has here. This is the. Can you see it from the back more or less?
Kind of, yeah.
Okay. So this is here the calculator, and this is here the index. And we just grab them with a function that will get as an input the require, the module, and the exports. And the same here. And here we specified that the entry file is the second one, which is the index.js. And we will pass this structure to a bootstrap function. And this is here the bootstrap function. So what will happen when we call that function? Here it will start requiring the entry ID, which is the second one, the index.js. And if we start to execute this code in our head, what will happen is that this function will be called, and since it's not in the cache, because the cache is just an empty object, it will put in the cache an empty object that represents the module, and then it will call the function that belongs to that module, and actually it will start execute this function. And here what it does, it just wraps the original require function, so that when here we will require /calculator, we don't have a /calculator in our list of modules, so it will map it to this ID to 1, so that it will run that function. And yeah, so it will find that, and then it will be able to run the code independent of the file system. So it doesn't require a file system to run this code. Was this more or less understandable? Okay, so basically what we did, just as a recap, we wrapped our modules into functions, and we passed the require, the module, and the exports so that it can get it from the outside, and like that we sort of monkey patched those functions and objects. And this is actually how Browserify works. I don't know if any of you guys have used it. Nowadays we don't really use Browserify, but a couple of years ago that was the most popular bundler. And yes, what we can see here, that like that we didn't actually need to modify our modules. So here we just put the content of the index file, and here we just put the content of the calculator file. But if we somehow could modify the source code and replace this /calculator with 1, then we could remove this extra mapping, and we could remove this extra wrapping of require where the /calculator will be mapped to the module ID. And if we do that, we get this structure where for every module we just have the function without the extra dependency mapping, and here we can just pass require. And like that we have a little bit smaller bundle size, and it's also faster to execute. And this is actually how Webpack generates the bundle. So Webpack will modify the source code and and instead of the original module that you required or imported, it will put there the IDs. So if you look at a generated Webpack output, it's very similar to this one. And so this is what we checked here. It's available on a GitHub repository where you can see the generated output and even play with it if you are interested in that. So this is how we could implement a very naive CommonJS bundler, but it's not that trendy today because we have the ES 2015 modules. So nobody actually uses CommonJS modules on the front end. It's still used on the back end, but on the front end we started to use the ES 2015 modules. So let's see how we could implement an ES 2015 bundler if we can use our previous implementation that we did. But you might ask, why another module format? So why was the ES6 module format created that you can see here? So instead of the module.exports, we have a keyword export, and instead of require, we have an import from the given module. Basically, this small example already shows that this time it's built into the language, so it's not a module format that was invented and just implemented by using functions. It's using the keywords, and like that, it's much more powerful than CommonJS or the EMD modules. For example, it has better support for cycling dependencies. I linked an example that you can check out if you are interested in that. It's not strictly related to bundling, it's just an interesting topic that why is the ES6 module format more powerful with regards to cycling dependencies. And more importantly, and what it is related to bundling is that this is a static module structure, and it enables us to do optimizations like tree shaping. But what does that actually mean? It means that in CommonJS, this is a perfectly fine code. If you check here, there is no way of knowing which module you will require during build time, because it's method.random. So every time you run this code, you might depend on the foo module, or you might depend on the bar module. And that's perfectly fine using CommonJS. But you cannot do that with the ES6 modules. If you want something similar, you need to import both modules, because both might be used. And then you need to decide which one to use by using a ternary operator or something like that. But you depended explicitly on both modules. And because the module format statically or syntactically enforces you to specify which modules you need, we can analyze the code, and we can know during build time which modules are actually being used and which modules are actually not being used. And we will see it later a little bit more detailed why this is a huge thing and why we can do optimizations like tree shaping.